All right. Hello. Hi, everyone. 안녕하세요. My name is Ashely Alicea. I am an evangelist for media and entertainment at Unity Technologies. And what that means is that my day-to-day is focused on games and film creations made in Unity. I am based in Unity's San Francisco office in California, but I am originally from Dorado, Puerto Rico, so I'm a very far away from home. But I'm very, very excited to be here with you all. It's been wonderful getting to know all the amazing creations that you guys are making here in Seoul. And today I'm really excited to talk to you all about using AR Foundation for creating multi-platform AR. Now, I'm going to preface this quickly by saying, unfortunately, we've had a little bit of technical difficulties with getting the connector into my iPad and my phone. So when I do my demos, I'm kind of going to be showing you here like on my iPad screen. But who here saw the keynote? Raise your hand. Okay, some of you. So I actually did this demo as part of the keynote, and what I'm doing is a deep dive into it. So if you definitely want to see more about what I'm presenting here in this talk, you can check out the keynote to see the video of the full demo. But in this talk specifically, what I'm going to overview is how, what is handheld AR and how does it work. I'm going to define the core features of AR Core and AR Kit. And I'm going to review the features of AR Foundation and what exactly is AR Foundation. And then I'm going to go over some recent AR Foundation updates. And then I'll show you all how to get started with AR Foundation, how to create a quick basic application. And I'll do a deep dive into a demo, into the keynote demo that we showed yesterday here at the conference. And then I'll share some resources with you all. Sound good? Cool. So handheld AR, what is it? So in the industry right now, we have several different ways of doing augmented reality, either through the phones or through wearable headset devices and more. Specifically in this talk, what I'm going to go over is handheld AR, so augmented reality for phones and for tablets. Now, what are the core features of mobile AR SDKs? Kind of regardless of what you're working in, you're going to find some core similarities, and that's going to include plane finding, being able to use your device to detect horizontal and vertical planes, position tracking, being able to track your device's position in space, its rotation, its orientation, and more. Really good for capturing things like motion paths. And then light estimation, and which takes the ambient light value of your surroundings and applies that to the objects in your scene. Now, over the past week, there's actually been a lot of updates in the AR space. So a new kind of core feature that you're going to find between both AR SDKs is face tracking. I'll dive into that a little bit, but there are a lot of brand new updates on that front as well. So the really important thing that we recommend to people when working with AR and fiddly microphones, one second. It keeps poking me in the face. All right. There. You guys can hear me, right? Okay. So the thing about AR is that the more you understand about your environment, the more realistic and immersive experiences you can create. Right? So there's going to be additional features in each AR SDK that will help you achieve those goals. The first of this is AR Core, which is Google's solution for augmented reality. Now, in our partnership with Google, they actually maintain the AR Core SDKs. I'm so sorry about this microphone. Okay, I give up. So, AR Core is Google's solution for augmented reality for Android devices. Now, they actually maintain the SDK and plugins for you. And so, they also include, with AR Core, a bunch of sample scenes for you all to reference and play with and tinker with and use for your own creations as you're learning how to use AR Core. Now, AR Core has a couple of unique features, and that includes oriented feature points. So these are kind of unique elements used for tracking that help you basically get a normal off a directional vector when you're doing AR. So for example, in this GIF that I have here, we have, we're placing the little Android characters on the laptop, but the laptop isn't a plane. So normally you're doing plane detection, and Wait, could somebody from AV come help me with the microphone? Or I don't know where he is. Okay. So anyway, AR Foundation. So so here we're tracking the planes, right? You could see the plane being tracked on the desk or on the floor and the walls, but the laptop itself is in the plane, yet we're still able to place objects on it. That's because we're detecting an oriented feature point on the laptop. And it also knows that the laptop is at an angle. So that's why when we place the object in the laptop, it's able to place the Android at an angle appropriately in the computer. So another thing is cloud anchors, the ability to create multi-platform, multiplayer experiences in augmented reality. You can place an anchor, push that to Google services, and then somebody else with augmented reality on their phone can detect the same kind of environment, pull down the same anchor, and access the same type of experience in their device. Now, we also have face tracking. So face tracking is actually brand new to AR Core. It came out like right before I went out on this trip, and so it's no computer vision based face tracking. So it's very different than ARKit face tracking, which I'm going to explain in a minute as well. But essentially, it uses computer vision to do a face tracking and apply augmented reality to your face. We also have instant preview. So instant preview can push an APK to your device and sends AR data back straight into your editor to use for debugging. And then we also have augmented images. So AR Core and ARKit both support this in different ways. And AR Core also just released a big update for augmented images just this past week. But the kind of main gist of it here is that you have an image, you can track it using AR Core. In the past, you could only just track an image, but now with the new updates, you can do, thank you. You're my hero, yay. All right, wait, can you guys hear me? Am I audible? Okay, cool, all right. Wonderful. This is so much better when it's not like poking me in my face. Okay, now I can get really, really excited about AR. Now, where was I? Augmented images. So augmented images, you can track images in a space with AR Core. You can now move the images around and it tracks the image as it's moving as well. And so really kind of as more features are being released across both these AR SDKs, you'll find that they're often more and more becoming similar as the kind of technology gets more advanced. So we also have ARKit. So ARKit is Apple's solution for iOS devices. So this is actually a plugin that's maintained by Unity. But we do work closely with Apple to make sure that it's always updated and maintained. So for example, when an announcement is made at one of Apple's conferences like WWDC, we normally have worked with them already and have whatever kind of ARKit feature they announced ready to use in the editor. Now, ARKit includes 40 sample scenes for all types of different features that you could use for your projects for reference in Unity. And with the iPhone X, you can do face tracking, and that's also included in the umbrella of kind of the ARKit platform. And that's also included in those samples. Now, what kind of features are unique to ARKit? World maps. So world maps, what they do is that they scan the environment, and they save point cloud data as a file on disk or as an asset. So you can scan an environment, share it to a friend's device, and you can relocalize together in the same AR space. It's what you see over here in this GIF image. We have two people using different devices, but they're both able to place the little orbs in space, and they can both see each other place those orbs. Now, images. So augmented ARKit supports augmented image recognition and tracking. So images either static or moving around. And then we also have object scanning. So I love object scanning. It's similar to the world map, except you can scan an object and keep that object scan data on file. And then when you use that in an AR experience, for example, I can go ahead and use ARKit and scan this water bottle. And let's say some of you have this water bottle, and you take your ARKit device and you scan it. If I applied a particle effect on mine and give you the same app, it'll also apply a particle effect on your water bottle. So it's really, really cool. I think it's really fun. Face tracking with iPhone X uses blend shapes instead of computer vision. So it's also cool because it recognizes your tongue and such when you're talking and doing face tracking. And what it does is that it applies a transform point to your face, and then you could use that and reference that for your AR experiences. Now, so it also allows you to use to mesh the geometry of your face, and it includes 50 blend shapes, so you're able to detect the different kind of expressions that you're making in augmented reality. Now, and you could use this to apply logic, do facial animation rigging, and more. One of my favorite AR kit experiences is we showed it at Unite Los Angeles about a year or 2 years ago, and we have a AR kit, iPhone X, and we are looking at it. You're making a bunch of different faces, and you're controlling a little girl character on the screen who also makes the same faces along. So that's really cool. And we also have environment probes. So environment probes are awesome because when you place an object in the world, you can use environment probes to reflect its surroundings onto the object. So what it does is that it creates a cube map, and then the cube map is then assigned to a reflection probe in Unity, and then you can and then you can see the reflections on the object. Now let's see. So what is AR Foundation? Now, we talked about the features of AR Core and AR Kit specifically, but what is AR Foundation and what makes it unique? And so essentially what it is that we're combining these core features of AR Core and AR Kit into AR Foundation. Now, AR Foundation is a multi-platform API for both AR Core and AR Kit applications. It allows you to combine your code into a single project and deploy to both platforms. So this means you're developing your AR application once, and then you could port it. You can then build it to AR Core or AR Kit devices without having to make a bunch of changes. Now, if you currently develop for AR Core or AR Kit, how many people here are AR developers? Raise your hand. Okay, a bunch of you. Excellent. So a bunch of you are familiar kind of with this process here. You have your AR Core app, and then you work with the Google AR Core SDK and the AR Core SDK plugin in Unity, and then you build it for your Android device. The same thing with Apple AR Kit. But with AR Foundation, what it does is that it removes the need for that standalone plugin, and we use the AR Kit and AR Core XR packages that you get from the package manager. So, and AR Foundation as well, you can get it through the package manager. And by using these packages together, it allows us to update them without having to wait for full editor releases. So this means that we can make sure that these packages are always updated for the new features of AR Core and AR Kit, and you don't have to wait for the next editor update to be able to access those features. Now, one thing to keep in mind is that AR Foundation was originally created to be used to be shared by both platforms, but we're evolving it to be able to support functionalities unique to each platform as well. So for example, if you want to do 3D object scanning with AR Kit, but that's not available in AR Core, you can still work with it in AR Foundation. Now, AR Foundation today, the status of it right now. So it's a preview package that you can get through the package manager. And like I mentioned, it covers the core functionality of AR Core and AR Kit. And it does the kind of core features like horizontal vertical plane finding, hit testing, light estimation. And it has unique camera APIs as well that allow you to do things like computer vision. So, and you can only access these camera APIs if you're using AR Foundation. And we also support lightweight render pipeline. So for those of you who saw the keynote demo, you might recognize the character here from our most recent AR Foundation demo. So this photo doesn't do it justice, but she looks amazing, especially when I kind of look up close at her. And we're able to do that thanks to the power of the lightweight render pipeline, which is supported by AR Foundation. Now, and then we also have the AR Foundation Samples project. It's an awesome reference to use that we created ourselves at Unity to show you examples and references that you can pull and use for your own projects of how to use all these different features using AR Foundation. So kind of the goal here is to make sure that that kind of AR Foundation column is fully green. But this is what AR Foundation is supporting right now and what we hope to support in the future. And so note that features that are similar between the two are already supported. And I just kind of made a quick edit because we just announced this morning that environment probes for ARKit are now officially supported through AR Foundation. We also support face tracking as well for ARKit. Now, remoting and simulation is available in preview mode through AR Foundation. But note that you have to use if you want to take advantage of the lightweight render pipeline for AR Core ARKit, you will have to use AR Foundation as well. Now, what's going to happen for the future of AR Foundation? So our goal is to achieve feature parity with AR Core 1.7 and ARKit 2.0. Now, we're also going to be supporting wearable AR devices. So right now, the focus is on the handheld stuff. But like I mentioned, there's a lot of augmented reality there that uses headsets. So we'll be working to expand our support to those kinds of devices as well. We'll also be releasing AR Remote. So if you saw the keynote, you saw me demo this technology where we were able to connect an AR-enabled mobile device to the editor wirelessly to test our AR applications. And then we're also going to have simulation available. So if you don't have an AR device, you can still simulate and do testing in your editor. Now, where to get AR Foundation? Like I mentioned, how many people here use the package manager? Raise your hand. Okay, so a couple of you here haven't heard of it. So if you haven't been using the package manager, you definitely need to check it out. So the package manager is where you can get all the tools and kind of preview packages and more that Unity's working on straight into your Unity project. No need to search online for a project you need or a package you need, or going to a GitHub, cloning the repo and more. You can get it directly into your projects by using the package manager. You get a little window like this. So to use AR Foundation, you want to go to the package manager and download AR Foundation package, AR Core package, and the ARKit package as well. Once you have these three, you're ready to get started with AR Foundation. Now, it's a lot more fun for me to show you how this all works, so I'm going to jump into a live demo in the editor. And what I'm going to do is just show you how to create a base, kind of basic AR Foundation application using the AR Foundation samples, so when you guys get home, you can download it and you already know how to get started. Bless you. Now, so here we have a base scene in Unity. The only thing I have here is a directional light. So what I'm going to do is I'm going to take this scene and turn it into, not again. Let's see. If I turn off PowerPoint, it should work. Please. Please. You can do it. I believe in you, monitor. We did it. Oh, careful. Oh, and then I go here. No, I lost my mouse. Okay. Live demos. Fun times. Yay. Okay, so so here I have a blank Unity scene. And what I'm going to do is I'm going to add the core components of AR Foundation to create this base AR experience. Now, all I have is the directional light. And what I'm going to do is I need to start adding an AR session and an AR session manager. Now, these two objects are what I'm going to use to be able to tell my device, hey, we're running an AR experience. We need to use the camera, And so if I just right click in my hierarchy and I go to XR and I go to AR session, I create an AR session and I do the same thing, go to XR and create an AR session origin. Now when I make an AR session origin and I expand it, you see underneath I have an AR camera. Now the AR camera is where we have all the settings that affect how we take in the feed from our camera and our device into our application. In this case, since I'm using the lightweight render pipeline, one of the first things I want to do is make sure that I apply a custom renderer to my AR camera, and I add the lightweight render pipeline renderer asset that you get when you have a lightweight render pipeline project. Now my camera feed will effectively use the lightweight render pipeline, and next thing I'm going to do is add a script for light estimation. So you may have seen this in the keynote demo as well, but light estimation, like I mentioned before, takes the values of the lights in the room that you're in and applies them to the game object. So I'll do add component and add the AR camera option script. If you download the AR Foundation samples, you will have all these scripts available for your projects as well. I'll just check off light estimation so we can have that for our spheres in our project. Now, the next thing I want to add are, when you're detecting, and you might have seen this in AR applications, you can detect a plane, like the floor or the wall, or you can detect point cloud data, but you need a way to visualize it. You need some kind of visual indicator for people to know that these are actually being scanned. So to do that, we'll right-click and add an AR default point cloud. Now by doing this, I get an asset here that is essentially a particle system, and I can adjust it how I want it to be to display the point cloud data in my AR application. Now just to keep this simple, I'm going to go ahead and change the color. It's like a nice bright blue color. So when we see the point cloud data in our application, we're going to see little blue dots pop up everywhere. Now what I'm going to do is save this as a prefab by dragging it down to my project window. I'm going to delete it from my hierarchy, and I'm going to reference it in just 1 second. Now, the next thing I want to add to my AR session origin is the place script. So place on plane. So here in the place on plane script is where I'm going to use to say, hey, when I tap on the screen, I'm going to need you to place an object, like a designated mesh I have, into my scene here. So I'll select the prefab here, and what I want to do is select this sphere. I have a sphere here in my project that I can use. And then I'm going to go to, where's my options here? I'm blind without my glasses. So, where'd it go? 1 second. All right. Now the next thing I want to add is this, the UI, because we can have an AR application, but if there's no kind of visual instruction or guidance for our application, people won't know what to do. So AR Foundation samples comes with really great visual UIs that appear at the top of your screen that say, okay, move your phone to detect the plane, or tap to place an object once a plane is detected. Now this is already available for you in AR Foundation samples, and I have it saved here as a prefab in my project. So I'm going to drag that prefab and place it in my scene, and I have my screen space UI that will be readily applied to my AR application. Now, once I add that, I get the options for adding my animations, which are already set up, and then my plane manager. And what I want to do is I want to move the plane manager that I have here. So let's see. All right, so what I added here, one thing I forgot to add earlier is the reference for the AR Plane Manager and the AR Point Cloud Manager. Now that prefab that I made for the Point Cloud, this is where I add it into my project so that we know, so my app knows what asset to reference to visualize that Point Cloud data. So I'll go ahead and grab that AR default Point Cloud prefab I made and add it to the Point Cloud prefab. And to create an AR plane manager, default plane is the same thing. XR, create default plane. In this case, I created a specific custom one that I can go to and add here. So the AR feathered plane fade. I like this one. It comes with AR Foundation samples, and it kind of really nicely fades out the edges of your plane, so it kind of disappears as you keep panning across your screen. So now that I have both of those added to my AR session origin, the next thing I want to do is just build to my device. Now, sadly, this is the part that I'm kind of bummed out about because we don't have the HDMI connector working here. But I'll try to demo it, and hopefully you guys can see it here on my phone. I'll like run around and like show it to you guys. So here, very hard to see, but you can see I have a little kind of UI thing here. So it's saying, all right, move your camera to detect the plane. So I'm going to do that here on my stage, and a bunch of little dots are appearing now all over the stage. This is the AR plane manager, and that AR feather plane prefab that we dragged into our project, that's what it's referencing to create that overlay here on the stage. Now, once I have it, also we're seeing here lots of little blue dots pop up all over the stage. That's the point cloud data being detected here on the stage and visualized here on the phone because of that prefab that we made as well. And I've seen people create all sorts of different ways to visualize it, so it's really cool things that you can do. Now, all I need to do to place an object is just tap. Hard to see-ish, but there's a little orb on the floor, and it actually matches the lighting that's coming in from the stage light. So the lights here in front of me are casting a light on the top of the sphere, and it's casting a little shadow right behind it. So that's using the estimation. So if I keep tapping around here, you can see it's adding little spheres to the floor for those of you over here as well. Ideally, I wish I could show this on the computer. But you guys get the idea, right? In just a couple of clicks and a few different features that we added to our scene, we're able to create a base AR application where we could start placing meshes in our scene. Now, what I want to show you now is something a bit more interesting. Now, those of you who saw the keynote demo saw this as well. But now that you understand how to create a basic AR experience, I want to show you what something kind of really cool looks like here. Now, this looks a little bit familiar, right? So I have my camera feed coming in through my AR Foundation application. I have the UI button here at the top of the screen telling me, all right, move your device to scan for the planes. So I'll do that. Once it detects the planes here in my scene on the stage, I can tap to place an object. So what I'm going to do is I'm going to press this plant button here. I'm going to see if I can do it this way so you guys can see better. I'm going to place these plants, and you see that they're being placed here on the stage as I'm walking. You can see the plane here being detected and adding more plants as I go. So those of you over there can see a little bit, hopefully. So here now, we're able to add, basically we're just doing a raycast into the scene, and where we're hitting the floor, we're adding a plant. And I'll kind of explain more about how this works, but we're using a really cool way to make sure that we don't have a bunch of plants overlaid on each other. But then now I'm going to go ahead and, how can I do this? All right, without falling off the stage. All right, here we go. So here I have our Terraformer character that's part of our AR Foundation demo. Now, ideally I don't cut in front of her. Here we go. So here she is. She looks gorgeous. I super wish I could show this to you up on the stage, but check out the keynote if you want to see this in action. This is made using the lightweight render pipeline, so she looks fantastic. She's using light estimation here in the scene, so she's also getting the kind of light values here in the stage, and it's being applied to her shadow along with the plants. And then one thing I can also do is, wait, let me add her back. I got ahead of myself. I went and showed my favorite feature without showing this other cool thing first. So some of you may be familiar with shader graph in Unity. This is a cool way you can apply shader graph shaders to AR Foundation objects. So here you see that my character just disappeared. You can kind of see her a little bit because of her normal map, so you know she's there. But we created this really cool shader effect that we can apply through AR Foundation to our AR applications. And lastly, I'll bring her back here so you can see. And this is my favorite. So I'm adding a bunch of spaceships right now. These are all the spaceships from Megacity. So you see here I have this is like 6,000 plus something ships running in mobile AR at 60 frames per second. Runs really well. It's really awesome. And so this is an example just, of how cool experiences you can make in AR Foundation. But what I want to do now is go into a deep dive of how exactly this all works. All right. Yay. Cool. So the shader on the character that we added here to the stage. So she takes the ambient brightness from the camera feed and we apply that data to the directional light that we had in our scene when I set it up. And so for her shader graph, we're using a physically based render shader, and it allows us to get all that lighting data really easily. And all of this lighting data is also driven in real time. Now, so one thing that's interesting, and so let's see if I can jump here. So when we originally created this, so one thing I didn't demo here because we don't have a crew for the stage lights right now, is that if I were to turn off the lights, she would actually become shadowy, like she would become obscured because of that real-time lighting data detection. Now, we're able to, one thing we did was that we actually decided to multiply the lighting data that was coming in through shader graph to have her look more subtle and to have that shader transition be more subtle, because she looks way too dark in this kind of version, and we wanted to get something kind of like, a happy medium kind of place. So we multiplied the lighting data to brighten her up a little bit, and really kind of this ties into the whole theme of when you make your AR experiences look a lot more natural and less jarring and less weird, they're a lot more immersive, a lot more enjoyable for your audiences. Now, the way we make this work in the shader is by outputting the light through the emission, and that ends up lightening and darkening the character here. Now, that shader where she kind of like disappeared into the back, that's an interesting one as well. So that refraction effect is a combination of the settings in the lightweight render pipeline asset that we use, as well as a single node in the shader graph. So what we do is we make sure the opaque texture is checked off in the lightweight render pipeline settings. And that allows us to pull the camera's feed as a texture that we could use for our shaders. Now, this essentially gets applied to the digital objects that we have in our scene, and then we can apply it as a single node through shader graph. And so we're able to do interesting things like the refraction effect happening here on the character. Now, one thing I want to mention that I think is really cool is that we're not just affecting the camera feed, right? You see the plants behind her? They're also kind of refracted as well. That's also being pulled as well from the shader graph shader. Now, so our goal here was to make the character transparent, but we wanted to make sure that you could see her as well, that you knew she was there, because if we just applied the camera texture, then she's literally gone. There's no way you could see her. So what we decided to do was take that texture and apply it, but also make sure that you can see her geometry. So we make sure that you could see her normal maps, and we also scrolled her UVs. So like that kind of mirage effect that's happening in the shader helps you kind of recognize that her presence is there. Now this is a cool one as well. So one thing that we always tell people to really make sure you consider when you're developing AR applications is shadows. So when you have good shadows in your project, it helps make your experience feel really grounded. And that's actually a big part of what makes it feel like your object is there with you in the scene. So here, we actually have a special custom shader on a quad that's attached to the bottom of the character prefab so that it can pick up her shadow as she's walking around. Because when you think about it, when you have an object in your Unity scene and you apply a light to it, it applies the shadow on whatever game object you have underneath, right? But if we don't have a game object underneath her, it's not going to put one on the camera feed necessarily. So we place that invisible plane at the bottom of her feet so it catches essentially that shadow information. Now, what we did here is that we originally wanted to do this through shader graph, but we ended up creating a custom shader for this so we could just get really specific with how we wanted the shadow to show. And so it's this is definitely something that is maybe not as performant, but for example, you wouldn't want to do this for every single character and every single object in your scene to calculate all those shadows. But for your main character, your main object in your project that maybe might have a complex shadow, this is a great kind of thing that you could use for that. So in contrast, the plants handle their shadows differently. So what we do is that we have little blob shadows underneath them. And really for these plants, that's more than enough to create that feeling of them being grounded in the scene. And it's super performant. It's just a little tiny blob texture that's applied to the bottom of the plant prefabs. And then you're all set with your shadows. Now, I was mentioning before as I was placing the plants, you saw that I placed a bunch of plants, and as I was moving my iPad, there was spacing between each one of them. It wasn't just covering the stage with a bunch of plants. So why was that? So what we did is that we have the raycast essentially hitting the stage, detecting where the space is, the floor. And if it detects the floor, it actually checks to see if there is a plant nearby. So each plant prefab has kind of a detection sphere, essentially. And if we place a plant and we move our camera slightly, and the raycast still detects that it's hitting within that kind of influence sphere of that plant, it won't place another plant there. And so each plant has their own colliders as well to help with this detection. So that's how we're able to apply a bunch of objects in our scene without having them kind of pile and be on top of each other. It also has a really cool kind of toon kind of looking effect because we're using the same shader that we use for the Terraformer character. Now, here are some really cool resources that I want to share with you all for when you're making your AR foundation projects. Now, the key to all of this, in my opinion, is the AR foundation samples. These are available through GitHub, and you could download them, and you're free to use these in your own applications or tinker with them and see how each of these features work. There are so many AR foundation features, like I mentioned. We even made updates as of this morning. So be sure to go ahead and check those out on GitHub. We also have the AR Foundation manual that you can use if you want documentation to learn more. And lastly, I highly recommend to check out the Unity for Mobile AR Solutions page to see a lot of different ways that AR is currently being used, in particular AR Foundation. And hopefully it can give you a lot of inspiration and ideas for your next AR experiences. But I only have a few minutes left, so I'm going to wrap it up for now to take any questions. But I'll be here either taking questions now or outside afterwards, but thank you so much for attending this talk. I'm sorry about the technical difficulties. If you want to come actually check out and play with the apps here on stage, you're more than welcome to come up and try it yourself and ask me your questions, but overall, thank you so much.